let's continue for today's session. Last session we saw briefly how do we do the chart work. How do we attempt these questions? I briefly told you about the symbols which we use in chart work. So today we will proceed ahead. We will see some concepts related to taking bearings, position lines. So relative bearings, true bearing, gyro bearing, magnetic compass bearing. So we will see these concepts one by one. Then we will see the compass error, deviation and variation, and how do we obtain this compass error in chart work. So these are the topics which are planned for this session. So you have any questions before we proceed to the presentation?
No, sir, we can proceed.
Okay, so chalo beta, let's start the presentation. Give me a minute, I will set it up. Okay, so beta, this is what we did in the last session. I told you about the general instructions. How do we go ahead with chart work? Then we saw these symbols, DR, EP, fix, course steered, course made good, current, all these symbols we saw. And then I told you this 1, 2, 3 method. How do we attack a chart work question? First we understand it, then we make a rough diagram, and then we make the final plot. So now we are going to proceed ahead. Let's move ahead now. Now there are many calculations which are required when you convert the data from the text which is given in the question paper to what is required on the chart. Say for example, they could give you compass bearings of a particular object. Now for plotting on the chart, you need to convert them to true bearings. So before we start the plotting, we need to do many calculations like this. So all these calculations which you are doing, now sometimes in haste, especially in the exam conditions, people do these calculations on the calculator and straight away plot them on the chart. So the examiner may get confused, how did you reach to that conclusion? So all the calculations which you are doing, they should be shown on your answer sheet. So all calculations required for solving the problems should be shown in detail on the answer sheet. That is the formula, any formula which you are using, the values of each parameter, and the answer obtained. All this should be clearly mentioned on the answer sheet. Now, merely calculating the values by the calculator and writing the answer on your answer sheet or on the chart will not be sufficient. That leaves a lot of doubt in the mind of the paper checker, and it may result in losing of marks. Now, if some of the data is calculated by using the Norris table, so we may refer to Norris table, we may refer to deviation card, we may refer to luminous range diagram. So whatever data we obtain from any of them, please mention the name of the table, or you have got this data from the luminous range diagram on your answer sheet. Now, after you complete a particular question, erase all the extra or unnecessary lines or markings which you may have drawn on the chart during plotting. So all these lines, all these markings which are not relevant to the plot, they should be removed, they should be erased to avoid confusing the examiner.
Beta, all okay up to here? Any doubts? Okay.
So only keep the required item, the relevant items, which are part of the plot. Now let's move on to the concept of position line. We will understand what is a position line, and we will understand how the information regarding a position line is provided to us in Chartwork questions. A position line basically is a line on our chart on which the vessel's position lies. So if we have a PL, we know that the vessel's position will lie on that position line only. There are different methods with which position lines can be obtained. So we will now see what are the different methods with which PLs can be obtained and how the information about the position lines is provided to us. Okay, now let's go into different methods with which position lines may be provided to us. Now, one of the method by which position lines can be provided to us is by way of visual bearings. So visual bearings of an object can be obtained by using different instruments. You can get the bearing of a object using a gyro compass. Now, if a gyro compass bearing is given to us, we need to apply the gyro error. Gyro error will also be given to us in the question. We need to get the true bearing of the object for plotting on the chart. Now, whenever we plot on the chart, we always plot true bearings. We never plot compass bearings. Gyro compass or standard compass bearings are never plotted on the chart. Now, if a compass bearing is given to us, then to convert it to true bearing, we need to apply the compass error. Now, compass error is a combination of deviation, which is obtained from the deviation card for a particular compass course, and variation, which may be given in the question paper, or the variation may be picked up from the chart. It is mentioned in the question paper whether you have to use a particular variation value or you have to pick up the variation from the chart. I will tell you how variation is picked up from the chart. So once you apply this compass error to the compass bearing, we get the true bearing, which we can then plot on the chart. Now the third method which could be used to provide us a bearing is by way of a relative bearing. Now, a relative bearing is basically with reference to the ship's head. Compass bearings are given with reference to the compass north. A relative bearing is given with respect to the ship's head. So we need to apply the ship's heading to the relative bearing and get the true bearing for plotting on the chart.
Beta, just give me 1 minute. I'll be back. Okay, beta. So, beta, let me know if you have any doubts till now, up to here.
No, sir, no.
So if we have the relative bearing, so we will apply our true course in order to get the true bearing from that.
Right, beta, that's right. If you have a relative bearing, you have to add the true course, or better than true course, you call it ship's head. So whatever direction the ship's head is pointing, you add that value to the relative bearing, and when you add it, it gets converted to true bearing. Okay, I will show you a small video, a 5 minutes video on relative bearing just now. Once we finish the doubts, I'll show you the video. Okay, so shall we move ahead, beta?
Yes, sir.
Yes,
Very
sir.
good. Let's go. Let me show you a video. Let me set it up. Just give me a minute.
In this video, I'm going to explain what is a true bearing of an object. Suppose this is a lighthouse and we need to find the true bearing of a lighthouse and we are on the ship. So
Beta, are you able to see and hear the video?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir. Okay, okay, beta, great.
this is the observer here and this is a true north. So this direction is a true north from observer. And this is a line of sight of object from the observer. So this angle is going to be true bearing of this lighthouse. Well, I can explain this that the true bearing of an object is the angle at the ship. That means that is observer between the geographical north or true north and line of sight of object from the ship. So this is a 0, 0, 0 degree. This is a 0, 0, 0 degree, that is true north. This is 090 degree. This is 180 degree. This is 270 degree. And this is 360 degree, which is again 000 degree. So we can say that the bearings are measured from 000 to 360 degree, but in clockwise direction.
So beta, this is the concept of a true bearing. A true bearing is basically measured with reference from true north. You measure it in a clockwise direction, and it starts from 000 and it goes up to 360 where it becomes 000 again. So this is the concept of true bearing in three-figure notation or true notation. So is this clear beta up to here? Any doubts? Okay, very good. Let's continue then.
Direction. So this is called clockwise motion. Now let us look again. This is true north. This is observer. This is the object, say lighthouse. And this is the line of sight. So we can say that this is true bearing. However, the ship's head is in this direction. So we can say that this angle is a relative bearing. The relative bearing is defined as this is an angle at the observer between the ship's head and line of sight of object from the ship. Relative bearing is measured clockwise from 0 degree to 360 degree, and this is measured from the ship's head. Well, the 000 degree is the ship's head, and that's the only difference from true bearing. So let's have a look here. Suppose this is a vessel, and this direction is true north, and suppose this is an object. So this angle is going to be true bearing. Well, if this is the ship's head is in this direction. This is the fore and aft line. So this angle from the ship's head to the object, to the line of sight of the object is called a relative bearing.
So is this clear beta? Is the concept of relative bearing clear?
सर अगर जो ये लाइट हाउस हमारे पोर्ट बाव पे होता तो हम इसको क्लॉकवाइज मेजर करके ये 300 समथिंग होता हमारे लिए रिलेटिव बेयरिंग.
Right beta, that's right. We measure it in the clockwise direction only. So even if it is on our port side, हम इसे clockwise ही measure करते हैं. The angle in that case would be close to 340, 350, that way.
Okay, sir.
Okay.
Is called a relative bearing. Now let's have a look here. Suppose this is ahead, this is ester, and this is the object. So this angle is the relative bearing. I just changed the configuration. This one is called starboard beam. This one is called port beam. Well, 45 degree to this. This is called starboard bow, and this is called port bow. Similarly, this is called starboard quarter, and this is called port quarter. So relative bearings are important as collision avoidance rules use reference of relative bearing. Basically, these relative bearings are the direction of other ship from on ship's head.
So beta, this is also clear. You see the directions starboard bow, starboard beam, port beam, starboard quarter, port quarter. So whenever directions are seen or referred to in chart work in relative bearing, whenever they tell you this is the lighthouse was on our starboard beam, they are giving us a relative bearing of 90 degrees. So whenever they refer the lighthouse was on a port beam, this is again a relative bearing, and port beam is at a relative bearing of 270 degrees. So beta, just now give me 1 minute. I had a network outage, so this technician has come. So you have a look at this diagram. I will just get it done. Give me a couple of minutes. Huh?
Okay.
Okay. Okay, beta, thanks for waiting. So that technician had come actually, and the problem is sorted out now. So let's continue. So these are the relative directions which are sometimes given to us in the Chartwork questions. They sometimes tell us a lighthouse is on the starboard beam. Sometimes they say lighthouse is on the port beam. So we should know how to find out the bearing of that lighthouse. So once we know this concept of relative bearing, it can be easily found. So let's proceed ahead now. Any doubt in your mind till now? Okay, great.
And this is called port quarter. So relative bearings are important as collision avoidance rules use reference of relative bearing. Basically, these relative bearings are the direction of other ship from on ship's head. Now let's talk about conversion of bearings. So relative bearing plus true course will give you true bearing. Let's take this example. Suppose relative bearing is 210 degree and the true course is 250 degree. Then true bearing is 210 plus 250, that is 460 degree. However, the bearing cannot be more than 360 degree. Bearings are measured from 0 to 360 degree. So we need to subtract this 360 degree. The bearing is 100 degree. Let me explain from this diagram. Well, this is the ship's head. So the true course is 250 degree. That is this angle. From true north to the ship's head, that is 250 degree. Now the relative bearing is 210 degree. That means this angle is 210 degree. Well, the true bearing is going to be the sum of that 210 plus 250, that is 460. However, we need to subtract this 360 degree. So the true bearing is from here to here, which is 100 degree.
So did you understand this diagram, beta?
Yes, sir.
Okay, all right. So the basic principle is if you are given a relative bearing, you have to add the ship's head to it and then you will get the true bearing. And anytime the bearing goes greater than 360, so we have to subtract a 360 from it to bring it within the valid range. The bearings always lie between 000 and 360. अगर कभी भी ये 360 से बड़ी वैल्यू आ जाए तो आप उसमें से 360 सब्ट्रैक्ट कर सकते हो, और कभी भी अगर किसी कैलकुलेशन में आपकी बियरिंग नेगेटिव में चली जाए, माइनस में चली जाए, तो आप उसमें 360 डिग्री ऐड कर सकते हो टू गेट द करेक्ट बियरिंग. सो क्लियर टू एवरीवन बेटा?
Yes, sir.
Very good. Let's go back to the presentation now. So now beta, I will refresh the concept of variation and deviation. So what is variation? What is deviation? How are these two applied to get the compass error? ये अब हम आगे देखने वाले हैं. So let's see.
Let's now refresh the concept of compass error, which consists of variation and deviation. So we are going to first discuss about variation. Magnetic variation is the angle between magnetic north and true north, and it is caused by the different locations of the geographic North Pole or the true North Pole and the magnetic North Pole. So you can see in this diagram, in the green color, we have the true North Pole marked, and in the blue color, you have the magnetic North Pole marked. Now you can see they are at different locations. The true North Pole is basically the point from where the axis of the Earth pass through the Earth's surface. We know the Earth is rotating on its axis from west to east. Now this axis passes from the surface of Earth at 2 points. Now these 2 points are known as the geographic poles or the true poles. So the true North Pole is marked in green color here. The magnetic North Pole is decided by the magnetism of the Earth or the magnetic properties of the Earth. Just like every magnet has 2 poles, the red and the blue pole, similarly the Earth also has magnetic properties, and it has magnetic North Pole and magnetic South Pole. Important thing to understand or know here is that these magnetic poles are not located at the same place where our geographic poles are or the true poles are. They are at a different location. Also, the location of magnetic poles is not permanent. It keeps on shifting. So variation, what we are talking about here, is the angle at any particular position on Earth. It is the angle between the magnetic North Pole and the true North Pole. So you can see here in the diagram, this variation is shown here as an angle between these 2 poles, the magnetic North Pole and the true North Pole. Variation will differ from place to place. So as the ship changes its position, the variation also keeps on changing. You can visualize it here in the diagram. Now, as the position of the observer keeps on changing, the angle between the magnetic and geographic North Pole will also keep on changing. Variation is not dependent on ship's head or the course. As you can see, the ship's head or the course which the vessel is steering has got no role to play in the variation. It is entirely dependent upon the position of the magnetic poles and the geographic poles. Now variation is provided to us in the question paper in 2 different ways. One, they could mention you what is the variation to be used for solving the questions. Let us say, for example, they will give you a value of 5 degrees east. So this is a standard value to be used when you are plotting any of the Chartwork questions on the chart. It is mentioned in the notes which are given in on top of the paper. So that is one way in which variation can be provided to you. It can be simply picked up and used irrespective of where the ship is, anywhere on the chart. Now, the second way in which it could be given is they could tell you to use the variation as mentioned in the chart. Now, if it is given in this way, then we will have to find out what is the variation at a particular place and then use that variation in our chart. So the next question which comes in our mind is how to pick up the variation from the chart. So variation value is mentioned in all the compass roses. You have the compass roses at different locations on the chart. So the variation in that area is mentioned in the compass rose. Now, as I told you that these magnetic poles keeps on changing their location. So year after year, the value of variation also keeps on changing. So how to represent this change in the chart? So let's see now, how do we pick up the variation from the chart and how do we account for this change?
Now, before I go into the video for picking up variation from the chart, any doubt up to here, beta, in this slide?
No sir, but I was asking variations are जैसे हम higher latitude पे आते हैं variation increase होगा sir.
Not necessary, beta. It can increase also, it can decrease also.
Okay.
Okay, it can vary in any way. I will give you an example. Let us see that from this position. I hope you can see the cursor.
Yes sir, yes sir.
So let us say from this particular position, the ship travels in a particular direction. Let's say the vessel moves like this, and the vessel comes here at this location. Now, if the vessel is where the cursor is right now, you see both the poles are in the same direction, right?
Yes sir, the angle will be lesser.
So angle would be zero, almost zero at this particular location.
Yes.
Now let's assume a different scenario. Let's say from the starting position, the vessel goes to this location here, exactly middle of the two poles, midway of the two poles. Can you tell me what will be the variation here?
So 180.
Very good. It will be 180 degrees. So it can be very tricky when you go close to the poles. Variation can vary quite a bit. Even if when you move a small distance, the variation can vary a lot. So that is
Yes.
what happens when we go in higher latitudes. Okay. और कोई डाउट बेटा अभी तक?
No sir. No sir.
Okay, very good. बेटा इंग्लिश ठीक ठाक चल रही है? इंग्लिश इज ओके?
Yes sir, not an issue.
ओके, ऑल
Thank you.
राइट. कल बेटा इंग्लिश के बारे में किसने बोला था? आकाश तुमने बोला था बेटा?
No sir, मैंने था.
Who was there? आज इंग्लिश किधर है आज? Looks like he's not there.
वो मोर जितेंद्र ने बोला था.
जितेंद्र?
हाँ जी सर.
हाँ जितेंद्र भाई, इंग्लिश ठीक ठाक चल रही है?
बढ़िया सर एकदम.
ओके, वेरी गुड, ठीक है. ओके, सो लेट्स नाउ सी कि हम चार्ट से वेरिएशन को कैसे पिकअप करते हैं. सो आई विल शो यू ए स्मॉल वीडियो अगेन. उस वीडियो में हम देखेंगे कि चार्ट में कंपास रो से वेरिएशन को कैसे पिक किया जाता है. लेट मी सेट अप द वीडियो.
Hi, welcome to this short video, an introduction to variation. So, what is variation? Well, we know that all vertical lines on the chart point to true north. But we also know the magnetic north is not at the North Pole. In fact, it's moving. The difference between them is called variation. So, how do we calculate variation? All charts have the information needed to calculate the appropriate variation for the area. From this, we can convert magnetic compass bearings to true chart bearings and vice versa. Essentially, we need to know two things. Firstly, what was the variation in a given year? And second, what was the annual change? Both these pieces of information can be found on the compass rose.
ओके अब बेटा ध्यान से समझना है हमने इसको। अगर हमें वेरिएशन को फाइंड आउट करना है तो दो चीज़ों का पता होना चाहिए। एक तो ये पता होना चाहिए कि गिवन टाइम पे, किसी भी टाइम पे, किसी भी ईयर में उस जगह पे वेरिएशन कितनी थी। ओके, जैसे इस कंपस रोज में यहाँ पे इन्होंने हमें ये इन्फॉर्मेशन दी हुई है। इन्होंने इन्फॉर्मेशन दी है 7 डिग्री 20 मिनट वेस्ट, ये वेरिएशन थी। और ये कब थी? दिस वाज इन ईयर 2005। सो अभी इसको मैं हाईलाइट भी करूँगा, इट विल बी जूम्ड। सो ये जो वेरिएशन थी इट वाज देयर इन 2005। एंड इसके साथ दूसरी चीज़ जो यहाँ पे लिखी हुई है ब्रैकेट में, वी विल जूम इट इन आफ्टर सम टाइम। दिस टेल्स अस कि भाई हर एक साल वेरिएशन में कितना चेंज हो रहा है। यही दो चीज़ें हमें चाहिए, एक पर्टिकुलर डेट पे या ईयर में वेरिएशन कितनी थी और हर एक साल में वेरिएशन में कितना चेंज हो रहा है। ये दो चीज़ें हमें चाहिए। अभी ये दो चीज़ें हम यहाँ कंपस रोज से पिकअप करेंगे। सो अप टू हियर क्लियर?
यस
Yes, sir.
ओके, वेरी गुड।
How do we interpret the compass rose data? The two pieces of information are written along the arrow. In this example, magnetic variation was 7 degrees 20 minutes west in 2005. The part written in brackets tells us what the annual change to variation is. In this case, 8 minutes east. Using this information, we can see that it is 13 years since variation was 7 degrees 20 minutes west.
अब बेटा दिस वीडियो वाज मेड इन 2018। 2018 में ये वेरिएशन को कैलकुलेट कर रहे हैं। सो इन्होंने जो डिफरेंस निकाला है वो है 13 इयर्स। सो 2018 में दिस वीडियो वाज मेड एंड वेरिएशन जो हमें दी थी वो 2005 की वेरिएशन थी। तो डिफरेंस आ गया 13 साल का हमारे पास। अगर हम 2021 में इसकी वेरिएशन को निकालेंगे तो ये डिफरेंस 13 की जगह पे 16 साल का हो जाएगा। ओके बेटा, अंडरस्टूड?
Yes, sir.
यस सर।
वेरी
सर
गुड।
एक क्वेश्चन था सर, कैन आई आस्क?
हाँ बोलो बेटा।
सर ये जो एनुअल चेंज की वैल्यू होती है सर, ये कैसे पता चलती है सर कि कितना में हर जगह पे एनुअल चेंज डिफरेंट होता है, तो ये कैसे पता चलता है सर जो चार्ट पे मार्क होता है?
ओके बेटा, दिस इज डन। इसके दो मेथड होते हैं। लेट मी बी फेस टू फेस विद यू। इसको पता करते हैं साइंटिस्ट्स और इसके दो तरीके होते हैं। एक तो पास्ट में जो वेरिएशन है उस तो हमें पता है, राइट, कि 2015 में वेरिएशन कितनी थी, 16 में कितनी थी। लेट्स से आज हमें ये फोरकास्ट करना है कि लेट्स से वी आर एट सम पोजीशन इन नॉर्थ इंडिया। दिल्ली में बैठे हैं हम लोग सारे और हमें पता करना है कि दिल्ली में अगले साल वेरिएशन कितनी चेंज होगी, व्हाट विल बी द चेंज। तो ये दो चीज़ों पे डिपेंड करता है। एक, पिछले ईयर्स में कितना चेंज आया है। हम ये देखेंगे 2020 और 2021 में कितना चेंज आया, 2019 2020 में कितना चेंज आया, तो उससे हमें एक आइडिया मिल जाएगा। और दूसरा, इसी के बेसिस पे होती है फोरकास्ट। अब ये जो फोरकास्ट होती है ये साइंटिस्ट बहुत सारे फैक्टर्स के साथ इसको कैलकुलेट करते हैं। इनमें क्या होता है, देखो अर्थ के अंदर ना बहुत सारे क्रस्ट के नीचे मोल्टन मेटल्स हैं, लावा इज़ देयर, मोल्टन मेटल्स आर देयर, उनमें बहुत सारे मैग्नेटिक मटेरियल्स हैं, वो मूव करते रहते हैं। ओके, टेक्टोनिक प्लेट्स मूव करती रहती है ना, नीचे जो लावा है वो भी मूव करता रहता है, तो अर्थ के अंदर जो मैग्नेटिक मटेरियल है उसकी मूवमेंट होती है। इसी मूवमेंट के बेसिस पे वो वेरिएशन की एस्टिमेट करते हैं कि कितना चेंज होगी।
ओके ओके, थैंक यू सर, थैंक यू सो मच।
अब ये आपसे रिटन एग्जाम में कोई नहीं पूछेगा,
सर ये बस जनरल नॉलेज के लिए पूछा था।
राइट बेटा, सो दिस इज डिफरेंट फ्रॉम चार्ट वर्क. Somebody may ask you in orals, so if you answer it this way, excellent. Okay, let's go back. Let's go back. So हमें 7 degree 20 minute variation मिली 2005 में, and every year it is changing by 8 minutes east. और अब हमें पता करना है कि 2018 में वेरिएशन कितनी होगी.
And has an annual movement of 8 minutes east. From this, we can work out that variation has changed by 104 minutes since 2005, i.e. 8 minutes times 13 years, which equals 104 minutes. We can convert this to whole degrees and minutes by dividing by 60, as there are 60 minutes in every degree. This comes to 1 degree and 44 minutes east. As the change since 2005 is east, in other words, opposite to the westerly variation, we need to deduct 1 degree 44 minutes from the 2005 variation to find out today's value.
ओके बेटा, सो क्या किया हमने, देखो 2005 में वेरिएशन थी 720, चेंज हो रहा था 8 मिनट ईस्ट. एक साल में चेंज होता है 8 मिनट्स का, तो हमने पता किया कि 13 साल में चेंज कितना होगा. सो 13 मल्टीप्लाइड बाय 8, हमें आंसर मिल गया 104 मिनट्स. सो वेरिएशन में जो चेंज आएगा वो आएगा 104 मिनट ईस्ट. अब अगर इसे डिग्री में कन्वर्ट करें तो ये बनता है 1 डिग्री 44 मिनट. तो वेरिएशन 1 डिग्री 44 मिनट ईस्ट इतना चेंज आएगा. अब हमारी शुरू की जो वेरिएशन थी वो वेस्ट थी, जो चेंज आ रहा है वो ईस्टर्ली है. इसका मतलब ये सब्ट्रैक्ट होगा. सो 720 वेस्ट में से 1 डिग्री 44 मिनट हम लोग सब्ट्रैक्ट कर देंगे और हमें 2018 की वेरिएशन मिल जाएगी.
Variation to find out today's value. 7 degrees 20 minutes minus 1 degree 44 minutes equals 5 degrees 36 minutes west.
So this is the answer which we get beta. 5 degree 36 minute west is the variation in 2018. So अब मुझे बताओ बेटा, इसमें कोई डाउट तो नहीं है किसी को?
सर
हाँ बोलो बेटा.
सर कंपास रोज पे वेरिएशन की जो वैल्यू है दैट होल्ड्स फॉर ऑल द एरिया दैट इज इन द चार्ट.
नहीं बेटा, चार्ट पे 2, 3, 4, 5 कंपास रोज हो सकते हैं. तो आप जहाँ पर भी हो, जहाँ पे भी आपके शिप की पोजीशन है, आपने ये चेक करना है कि सबसे नियरेस्ट वाला कंपास रोज कौन सा है और आपने वेरिएशन की वैल्यू उसी कंपास रोज से पिकअप करनी है.
ओके सर.
ओके, और बेटा और कोई डाउट? ओके, वेरी गुड. लेट्स मूव अहेड.
Now we know how.
ओके, ऑल राइट, दिस इज मोर और लेस डन. सो अब बेटा हमने देखा कि चार्ट में से हम लोग वेरिएशन को कैसे पिकअप करते हैं. हमारे पेपर में मोस्ट ऑफ द टाइम, ज़्यादातर जो क्वेश्चन दिए जाते हैं उनमें हमें वेरिएशन की एक फ़िक्स वैल्यू दे दी जाती है. दे टेल अस कि आपने सारे चार्ट वर्क के क्वेश्चन में इस वेरिएशन को यूज़ करना है. सो अगर ऐसा हो जाए फिर तो काम बहुत आसान है. हमें कंपास रोज को बिल्कुल नहीं देखना, हमें चार्ट पे जाने की ज़रूरत ही नहीं है, जो वैल्यू हमें दी है उसी वैल्यू के साथ हम सारे सवाल को सॉल्व करेंगे। बट अगर किसी पेपर में उन्होंने हमें ये बोला कि आपको वेरिएशन चार्ट में से पिकअप करनी है, तो उस केस में हमें ये प्रोसीजर अप्लाई करना पड़ेगा और वेरिएशन को कंपास रोज से जो भी नियरेस्ट है हमारे शिप के वहाँ से पिकअप करना पड़ेगा। बेटा आपके पास एमएमडी के पास्ट पेपर्स हैं? डू यू हैव?
यस सर, है सर।
वेरी गुड।
ऑनलाइन भी अवेलेबल है सर, एप्स पे अवेलेबल है।
वेरी गुड, वेरी गुड। सो अगर आप जाके चेक करोगे ना चार्टवर्क के पेपर में, आज पेपर्स खोल के देखना, तो चार्टवर्क के पेपर के ऊपर आपको नोट्स दिखाई देंगे। उन नोट्स में जाके आप पढ़ना कि वेरिएशन कैसे दी गई है। इज इट गिवन स्ट्रेट अवे और दे हैव रिटन वेरिएशन इज टू बी पिक्ड अप फ्रॉम द चार्ट? ओके, देन यू विल गेट एन आइडिया कि वेरिएशन हमें चार्ट में कैसे दी जाती है, क्वेश्चन पेपर में कैसे दी जाती है। So we are almost finished for our session. So let us stop it here. अगले सेशन में when we meet, then we will discuss about deviation and compass error, how to convert true to compass and compass to true. ये हम आगे देखेंगे. So any doubts till now?
No sir, thank you.
Very good.
Thank you, sir.
Great. So see you in the next lecture. Till then, bye bye.
I have one question sir. सर
हाँ,
जो चार्ट सिंबल्स एंड एब्रिविएशंस है सर इसकी आप कोई पीडीएफ या कुछ हम लोग को सेंड कर सकते हैं ईमेल पे, कुछ सॉफ्ट कॉपी या ऐसा कुछ?
बेटा अभी चाहते हो या थोड़ा रुक के भेज दूं, क्योंकि आई डोंट वांट टू ओवरलोड यू। मेरे
बाद
पास
में भेज देंगे, मैं पूछ रहा था सर कि बाद में या कभी भी भेज देंगे सर?
हाँ बेटा मैं भेज दूंगा। इफ़ यू से, अब तुमने पॉइंट रेज किया है तो मैं भेज देता हूँ। मैंने एक पीडीएफ बनाया हुआ है जो सिंबल्स हमारे पेपर्स में आते हैं, उन सिंबल्स का एक पैम्फलेट मेरे पास तैयार है, तो मैं वो आपको भेज देता हूँ। उसे मेमोराइज करना होता है बेटा। सो यू हैव टू रीड कि भाई ये सिंबल है और उसका ये मतलब है। सो यू कैन कीप ऑन मेमोराइजिंग इट, यू कैन कीप ऑन गोइंग थ्रू एंड कीप ऑन मेमोराइजिंग इट। सो आई विल सेंड इट टू यू, मैं ग्रुप पे डाल दूंगा बेटा।
ओके, थैंक यू सर, थैंक यू सो मच।
ओके बेटा, ओके ओके। और कोई डाउट बेटा? Very good, great. So let's break off and I will see you in the next session. Then till then, bye bye.
Thank you, sir.
Thank you, beta.
Thank you. Thank you, sir.
Thank you. Beta.